All right, so very good afternoon to everyone. A very good afternoon to all of you, my dear students. A very good afternoon to all of you. So, guys, I am here again with the 75 hard days challenge of physics, and this is the day fourth in the physics. Okay, so guys, we have started the 75 days physics challenge as you know it, and every day we are solving some questions of physics so that you get more and more comfortable in this subject and score maximum marks in the NEET examination. Okay, right? So I'm hoping that we have accepted this challenge and we are doing it. So, guys, who am I? So, I'm your physics educator, Dr. Umashankar Tripathi, and these are the brief credentials of mine. And I hope you are following this channel for all such, videos and all such content. So, let's start with the question without wasting any time. So we already have solved. So this is previously we have solved the questions of the chapter first, that is units and measurement. So as we have targeted at least some 50 questions are to be done in one chapter. So each day we are doing some 10-15 questions. So let's try this question. I'm very sure we can do it. Please go for it. The live students can comment and tell me in the chat that are you being able to do this question or not? Okay, what is the answer to the question? You guys can tell me that. The live students. I'm very sure we can do it. Please go for it. So it says in the relation x is equal to cos omega t plus kx, the dimension of omega is. Okay. So now please understand this. So see, this is cos omega t plus kx. So this has to be an angle, and this also has to be an angle. Okay. Now what is the dimension of an angle? So an angle is dimensionless. Angle is dimensionless. So angle is dimensionless. That means dimension of omega t. This whole thing must be m0, l0, and t0. So what is going to be the dimension of omega? So dimension of omega. So what is the dimension of this t? So it is t. So it is going to be m0, l0. Now t will go in the denominator. So if you see this in the numerator, it will be m0 l0 t minus 1. So what is going to be the option? The option is C option. I hope it is fine to everyone. Right? Now let's move to the next question. Very important, very frequently asked question. Right? Let's try this one. So here we go with the second question. A question of the vernier caliper. Please try it. I'm very sure we can do it. Please go for it. The live students can respond to me in the chat. चलिए. Let's try. So in a vernier caliper, it's not calipers actually. Vernier caliper, 10 smallest divisions of the vernier scale are equal to 9 smallest division on the main scale. Okay, so if the smallest division on the main scale is half millimeter, the vernier constant is. So what is going to be the vernier constant, guys? So basically, they are asking you the least count. So when they are asking the constant of any device, basically that is the least count. Okay, that is the least count. So if the smallest division on the main scale is half millimeter, if the smallest division on the main scale is half millimeter, then the 1 year constant is. So now see what is the information here with us. So in a 1 year caliper, 10 smallest division of the 1 year scale. So 10 division of the 1 year scale, that means 10 1 year scale divisions is equal to 10 1 year scale division is equal to 9 smallest scale divisions. So it is equal to 9 MSD. So 1 1 year scale division is equal to obviously 9 by 10 MSD. Okay. Now what is going to be the least count? That is the 1 year constant. Okay. It is going to be main scale division minus 1 year scale division. We very well know it. We have understood this, very extensively. So if I take MSD as common, it will, so I can write it firstly. MSD minus VSD is 9 by 10 of MSD. Okay. So can I write it like this? So MSD 1 minus 9 by 10. Okay, so what is going to be the MSD here? So here it says it is half a millimeter. So it is 0.5 and this is going to be 1 by 10 obviously. So it is going to be 0.05 mm. Now let's see the answer. Okay, so this is the C option, right? 0.05 of mm, right? I hope that's fine to everyone. Okay, now let's move to the next question. Let's try this one. Please do it. Please do it, beta. The live students can please try to solve this one. I'm very sure we can do it. Please go for it. Please go for it. I'm quite sure we can do it. No problem at all. Please go for it, guys. Please go for it. Any answers? Any answers? So what it says, so which two of the following five physical parameters have the same dimension? So some physical quantities are mentioned here. Okay, some physical quantities are mentioned here. So they are energy density, refractive index, dielectric constant, Young's modulus. So energy density, so Newton meter per meter cube, and Young's modulus, Newton per meter square. So they both have the same unit. So it is going to be the C option. I hope it is fine to everyone. Now let's try a very interesting question. Okay, please try it. I'm very sure we can do it. Please go for it. Very, very interesting question. Please try it. I'm very sure we can do it. Please go for it. Please go for it. I'm very, very sure that we can do it. There's no problem at all. Please go for it. So it says in the equation P plus A by V square, V minus B is equal to constant. The unit of A is. Okay. Okay. Please do it. The live students can respond to me. Very, very simple question, guys. Please answer it. So, sir, how we can do it? So, it says in the equation P plus A by V square, V minus B is equal to constant. The unit of A is. Now, please understand this. So, see, P plus A by V square, V minus B. So, we understand that two things which are getting added or subtracted, they must have the same dimension. Otherwise, how they can be added or subtracted? So that means that the dimension of A by V square, it has to be equal to the dimension of P. Okay. Sorry. It has to be equal to the dimension of P. Now, what is this V? So here V is volume, right? Here V is your volume. Okay, so this is Van der Waals equation, right? See, in the questions of this very chapter, you also need to, understand this, that sometimes some formulas could be used which belongs to the upcoming chapters. Okay, so P plus A by V square. So the dimension of A by V square must be equal to the dimension of P. It must be equal to the dimension of P. So what is the dimension of P, sir? So P is force upon area. Okay, force upon area. So what is the unit of force, sir? The unit of force is dyne. Okay, the unit of force is dyne, right? Yes, sir, absolutely. Okay, so see, normally we see Newton. Okay, but dyne is also a unit of force. We know it, so it is the CGS unit. Huh? So basically, when you see that options are there in the dyne, so it is all obviously beneficial that you answer in terms of you take the pressure in terms of the CGS unit. So in CGS unit, the pressure is going to be dyne per centimeter square, and it is to be multiplied with V square. So what is volume? It is centimeter cube and square. So it will become centimeter to the power 6 upon centimeter square. So this will become 9 centimeter to the power 4. 9 centimeter to the power 4. Right? Okay. Obviously, sir, very, very easy. No problem at all. Now, please understand this. Now, in this very same question, in the very same question, okay. Now, in the very same question, if I ask you what is the dimension of this B, what is the dimension of this B? Okay. Okay. So, sir, it has to be centimeter cube, right? Okay. Okay. It has to be centimeter cube. Why so? So, V minus B. V minus B. So, when it is V minus B, beta, when it is V minus B, so obviously B and V have the same dimensions, otherwise it cannot be subtracted. Now let's move to the next question. Please do it. So the dimensions of the Reynolds constant, the dimensions of the Reynolds constants are, what are the dimension of the Reynolds constants, sir? So see, Reynolds constant, that is the Reynolds number, is rho Vd by nu. Okay, it is rho Vd by nu. So now this is what? This is what, guys? So this is a dimensionless constant, na? This is a dimensionless number. So Reynolds number is used, in the fluid part of the physics where there are type of flow like laminar, turbulent. So we see that whether the flow is laminar or turbulent. So there we take help of the Reynolds constant. So Reynolds constant has no dimension. So when it is having no dimension, obviously it is going to become M0, L0, T0. Now let's try one more question. See, we need to do as many as question possible of each of the chapter, okay, so that we are good in that chapter, okay. Now please do it. Now let's try this one. Let's try. I'm very sure we can do it. Read the question carefully. Which of the following do not have the same dimensional formula as that of the velocity? Okay, so we have some parameters given, that is mu naught permeability, E naught permittivity, N is the frequency, L is the wavelength, P is the pressure, R is the density, omega is angular frequency, K is wave number. So what is the dimension of velocity? So it is LT minus 1. It is LT minus 1. Now clearly this is your answer. How come, sir? Omega. Omega is T minus 1 and K is what, sir? K is the wave number. So what is the unit of the wave number? So it is 1 by meter. It is 1 by meter. So it is L minus 1. So clearly this omega K do not have the same dimension. This do not have the same dimension as that of the velocity. Okay. Now let's try one more question. Okay, please try this one. What is the unit of magnetic moment? See guys, we can always try to solve the question. Please go for it. So what is the unit of magnetic moment, sir? So we know, sir, magnetic moment refers to the strength of the magnet. Okay. Okay. So its SI unit is ampere meter square or Newton meter Tesla. Right. So ampere meter square, according to the options in the question, the answer would be ampere meter square. Right. Now let's move to one more question. A very important question. Questions of these kinds are very, very frequently asked in the NEET paper. Okay. Let's try it. Please go for it. Very interesting. I'm very sure we can do it. Please go for it, Buddha. Please go for it. Very simple question. We have solved questions like this in our sessions, right? If you have any difficulty in any of this topic, you can watch the content session on this channel. Okay, we have covered all these concepts in the units and measurement chapter. We have completed it extensively. We have seen each and everything: what is error, how to measure it, what is dimension, what are the dimensions of various physical quantities. So many things we have seen. So please solve this question, guys. I'm very sure we can do it. It says an experiment is performed to obtain the value of acceleration due to gravity g by using a simple pendulum of length L. In this experiment, time for 100 oscillations is measured by using a watch of 1 second least count, and the value is 90.0 seconds. The length L is measured by using a meter scale of least count 1 mm, and the value is 20 centimeter. The error in the determination of G would be error in the determination of G would be. So, what is the time period? Okay, so what is the formula of time period? So, time period is given by T is equal to 2 pi root over L by G. Okay, so if I square this whole equation, can I have T square is equal to 4 pi square T square is equal to 4 pi square L by G. So from here G we can write 4 pi square L by T square. Okay. Now if I use the concept of the error, can I write delta G by G into 100 is equal to, so 4 pi, it is an numeric value, it is a constant, it is a constant. So it has nothing to do with the errors. So we can write delta L by L into 100 plus 2 times delta T by T into 100, where T is the time period of one oscillation. Okay. So now, what is the change in length? What is the delta L? That is error in the length. So length error is 1 mm. Okay. So can I write? So least count is the maximum possible error in the measurement from any device. So this is 1 and length is 20 centimeters. So taking care of the unit, it will be 200. Okay, plus 2. Now delta T by T. Sir, is it delta T and T? No, sir. This is a small delta T upon T. Okay, this is what we have learned now. Okay, so this is, so we require the error in the measurement of each oscillation, but we have error in the measurement in 90 for 100 oscillation. But we already have this idea now, so we have seen this, that delta T, small delta T by T is capital delta T by T. So your answer is not going to be any different if you write the least count and you write the measure time, okay, into 100. So when we solve it, what we are getting? When we are when we solve it, what we are getting? So when we solve it, we are getting 2.72%. 2.72%. So it would be B option. It would be B option. I hope it is clear to everyone, right? Okay. Let's move to one more question. So this we already have done, no? Okay. So guys, these questions I hope you were able to do perfectly. Uh, so let's try if I have some more questions. Okay. Okay. Can we please try this one? Yeah. Let's see if we can do it. I'm very sure we can do it. See some additional question I'm going to give you here. Please try it. Please try it. I'm very sure we can do. Please go for it. Please go for it. I'm very sure we can do it. So how can we do it? So it says if x is equal to 80 plus bt square, where x is the distance traveled by the body in kilometer, while t is the time in second, then the unit of b is. So we know, sir. What do we know, sir? So we know that in an equation, the dimension of the left hand side has to be equal to the dimension of the right hand side. Absolutely, sir. So, what is going to be the dimension of bt square? So, the dimension of bt square is going to be equal to the dimension of x. Dimension of x. So, it is given that the unit of x is kilometer. So, we know t square. What is the unit of t square? It is kilometer per second square. So what is going to be the option here, Vida? What is going to be the right option here? The right option is going to be equal to C option. Okay, right option is going to be equal to C option. Okay, okay. Now let's try one more. So basically, from tomorrow onwards, I think with this session we have done cumulatively from all the sessions, if we say. So we have somewhat completed. This is I think if you combine all the sessions till now, so this is the fourth day, and we almost have done 40 questions of the chapter. So from next day onwards, that is the fifth day, I'll be starting with the big portion, that is the portion of the kinematics. All right. Okay. So please try this question, Mira. Now it says if energy E, velocity V, and time T are chosen as the fundamental quantities, the dimension of the surface tension will be. So we can write surface tension. Okay. So let's call it S. So let's suppose it is proportional to energy, it is proportional to velocity, it is proportional to time. So e to the power a, v to the power b, t to the power c. Now what is the dimension of this surface tension? So surface tension dimension is mt minus 2, and this is proportional to energy. What is the dimension of energy? So it is ml square t minus 2. Now we'll raise it to the power of a. Then we have LT minus 1. We raise it to the power of B. And then we have T to the power C. T to the power C. So from here, can we write that A is equal to 1 right away? A is equal to 1 right away. Okay, so no worries. Now L is 2A plus B is equal to 0. Okay, so B is equal to minus 2. Okay, now minus 2a minus b minus 2a minus b plus c is equal to 0. Okay, plus c is equal to 0. So from here what we are getting with that? From here what we are getting? So from here we are getting how much? It is equal to minus 2 actually. It is equal to minus 2, na, t to the power minus 2. So see clearly minus 2, a minus b is 0. So c, right away c is minus 2. So what is going to be the option with that? The option is B option. Okay, the option is B option. Now let's try one more. Yeah, please go for it. I'm very sure we can do it. Please try. Please try it, my dear. So how do we do it? It says if dimension of critical velocity of a liquid flowing through a tube are expressed as this, and this, where eta is equal to eta rho and r are coefficient of viscosity, density, and radius of the tube respectively, find the values of x, y, and z. So how we can do it? So So critical velocity can be right. It is proportional to eta to the power x rho to the power y and r to the power j. So what is the dimension of this? So this is LT minus 1. Okay, what is the dimension of coefficient of dynamic viscosity? So it is shear stress into dy upon du. So it is going to be Newton meter square, Newton per meter square, dy is meter and it is meter per second. So it is basically Newton second per meter square, Newton second per meter square. So I may write it. So let's sort it out. So it is mlt minus 2 into t upon l square. So basically it becomes m l minus 1 t minus 1 to the power of x. Then we have rho. Rho is ml minus 3 to the power of y, and r is l to the power z. R is l to the power z. Right? R is l to the power z. I hope it is fine to you. Yeah. Okay. Now what we can do, sir? What we can do, so we can compare the power of the same basis. So I can see that x plus y is going to become 0. X plus y is going to become 0. Then we have minus x minus x. Okay, we have minus 3y and plus z. It is equal to minus x minus 3y plus z. It is equal to 1. Okay, it is equal to 1 and minus x is equal to minus 1. So clearly x is equal to 1, guys. Okay, now x is equal to 1. Let's see the option. So now C and D could be the option. Okay, now x plus y is equal to 0. So y is equal to minus 1. Y is equal to minus 1, right? Okay, y is equal to minus 1, right? Am I right? So okay, mx plus y is equal to 0. Then minus x, sorry, minus. So I just missed one thing. So see, just one moment, huh? See, if you miss something, the solution is going to be wrong. So minus x plus z, okay, it is equal to 1, right? Minus x plus z is equal to 1. Okay, not because, here L, so here L to the power 1. So what I'm doing, so I'm comparing the power of the same basis, right? So it is L to the power 1, then L to the power minus x and minus 3y plus z. And for t, it is minus x. Oh, I was doing right only. Oh, so it is going to be minus x is equal to Okay, it is equal to, okay, so I'm comparing the power of t, right? So minus x is equal to how much? It is equal to minus 1. So x is equal to 1. Okay, that's okay. So y is equal to minus 1. So we have x and we have y. So what is going to be the answer to it, sir? So obviously the answer is going to be the D option, right? Answer is going to be the D option. I hope it is fine to everyone. Yeah, okay. Well, let's try one more question. See, all these questions are going to help you a lot, right? Okay, let's try this one. I'm very sure we can do. Please go for it. Please go for it. How can we do it? So it says the velocity of v of a, see how easily we can do this question. So the velocity of a particle at time t, the velocity of a particle, the velocity v of a particle at time t is given by v is equal to at plus bt plus c, where a, b, c are constants and dimension of a, b, c are. Now clearly the dimension of c has to be the dimension of t. So the dimension of c has to be t. Now look at the option. We have only one option, that is having the dimension of c is equal to t. So this way you can save the time as well. Are you getting my point? Okay. It is very, very, very important that you save some time also in the examination. Okay. So not only solving the question, but saving time also is crucial. Okay. So let's try one more. Let's try this one. I'm very sure we can do it. Please go for it. I'm very sure we can do it. Please go for it. So how we could do it? So in an experiment, four quantities A, B, C, D are measured with percentage error 1%, 2%, 3%, and 4% respectively. Quantity P is calculated as follows. Percentage error in P is. So what is going to be the percentage error in P? So can we write delta P by P into 100 is equal to 3 times delta A by A. So we know how to deal into errors, right? Delta A by A into 100 plus 2 times delta B by B, B by B into 100, okay, plus delta C by C into 100 plus delta D by D into 100. Right now, in this case, see what is given. So delta A by A, it is 1%. plus 2 delta b by b, it is 2% plus 3% in error in the C, and in the D, how much is the error, guys? So in the D, the error is of 4%. So it is going to be how much? It is going to be 14%. Okay, so what is your answer to this question, sir? Obviously, this is 14%. I hope it is clear to everyone. Okay, okay. Now let's move to one more question. So I think in today's session we have done some more questions. Okay, more than 10 questions we have done till now. Now let's try this one. Please try it. I'm very sure we can do it. Very, very simple question. Very, very simple question of the errors. Yes, Andrea. Perfect. Now, can you answer this? Oh, I pasted the wrong question. Just give me a moment, guys. This, no, no. Okay, okay. I have pasted the correct question. Okay, let's do it. Sandra, you may please try this question. So in this session, how much question we have done? Let's see. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the 14th question of today's session. Okay, please do it. Can you answer me, Sandra? Very simple. Let's see if we can do it or not. So how can we do it? So it says the percentage error in the measurement of mass and speed are 2%, 3% respectively. The error in kinetic energy obtained by measuring the mass and speed is. So we know the kinetic energy is given by half mv square. So can we write the error in the kinetic energy? Okay, percentage. It is going to be delta m by m into 100 plus del 2 times delta v by v into 100, right? 2 times delta v by v into 100. So how much it is going to be? So the percentage error in this is how much? It is 2%, and percentage error in the speed is 3%. So this is going to be 8%. So that is going to be your C option. That is going to be your C option. I hope it is fine to everyone. Right? Okay. Okay. Yes or no? Yes or no? I hope it is fine to everyone. Right now, one last question. Okay, so that we do 15 question, na? So 14. So we already have done 14, but let's do one more. Very simple question. One question from the significant figure also. So from the next session onwards, we'll be beginning with the kinematics question. So we have done approximately 50 questions of this particular first chapter. So we are targeting to do at least 50 questions of our chapter, depending upon the quantum of that chapter. Okay. So what is going to be the answer to this? What will be the answer to this? Please think and tell. Please think and tell me. Actually, no calculation is even required in this. Yes, Andrea. What is going to be the calculation? So it says taking into account of the significant figure. So see, one can do one thing, sir, we start subtracting it, wasting our time. But if you know the rules well, taking into account of the significant figure, what is the value of this? So when two significant figures are subtracted, the final answer is rounded off to the minimum, to the number of decimal places as present in the least value of decimal, least value. Okay, okay. So sorry. So when two significant figures are subtracted or added, the final solution must have the same number of decimal places as present with the value with least decimal place. So in this, how many decimal places are there? What is in the least decimal place value? So it is two decimal place. So see, you need not to make any calculation seeing the option, because in only one option, guys, we are having the solution with two decimal places. I hope it is fine to you, right? Okay, okay. So, guys, that will be all. Okay, so in this session, we have solved some 15 questions of units and measurement. Yeah, no, 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 Sondria, you have given the wrong answer. See, this is how we do not, So if you subtract them in general way, you would be getting 9.9801. But the problem is that significant figures do not added and subtracted like this. Okay, there are rules of addition, subtraction, multiplication, and division of significant figures. So these are significant figures. So what are those rules? So see, on this channel, I have taught significant figure very exhaustively. I have given all the rules of finding the significant figure. I have given, everything that is required for the significant figure. So you can refer that video, and definitely you are going to understand all the concept of the significant figure. Okay, and this is prerequisite to this errors also. Okay, so I recommend you watch that session, okay, if possible. And from the upcoming session, so this was the fourth day of the 75 hard days physics challenge, and each day we are doing some questions. Okay, the sole purpose is that we practice questions and we come up with best results. So see, practicing question in physics is of utmost important. Okay, if you want to understand it, the way is through practicing. Okay, so today's session I'll be ending up the questions of units and measurement. That is the first unit, and from tomorrow we'll be moving towards a big unit of kinematics. Okay, so please don't forget to subscribe the channel if you haven't subscribed yet. And with this, thank you very much. Have a good day, and we'll see you in the next session.